Hello there. Welcome to the last topic in our module 7. What do we have here? A good day-to-day example. Let's jump into it. We call it the case study, and we're going to deal with a case of this coffee machine. Okay, coffee machine. I like a lot of coffee, so maybe I'm fond of solving the coffee machine problem. So what do we have? We have a tea coffee vending machine. It accepts a token or a coin and also gives an option for sugar. Of course, the picture shows a lot of menu items, but right now we are only talking about tea, coffee, and sugar. Okay, so let's do this. I'm going to get rid of all the markings, and we've already come up with a particular state machine. We have seen this earlier. Now let's build on this. So what do we have? We have three states. We came up with three states: idle, coin inserted, sugar button pressed. And as we do our work, what we are going to do is we are going to develop a graph. So what do we have? We have three nodes. Let us call the nodes A, B, and C. So what do we have here? In the idle state, without inserting the coin, when coffee, sugar, or tea is pressed, nothing's going to happen. Right? So that's where we start. So we have got this transition, this transition, this transition understood. The other model that we have is without inserting the coin, nothing should be given out. So that's what is happening in the idle state. The moment a coin is inserted, we get to a state which itself says coin inserted. And if the coin is expected to be returned because the user changed the mind, then we are looking at this state remaining in spite of the coin being returned. That looks like trouble there, right? So we got to now make sure that we have corrections made. Now, I'm going to make all the corrections with red. So the moment we are looking at a coin to be returned, we are going to go here. So this should not exist. If a coin is expected to be returned after pressing sugar, then as well we'll need to return back over here. This doesn't seem correct. So in idle, coin is pressed or coin is inserted. We move to coin inserted state. After coin is inserted, I could ask for a cup of coffee. So my assumptions are so, right, that I have first asked for a cup of coffee. Then the only thing that happens to me is I get a cup of coffee, coin is consumed, get a cup of coffee, and I return back to idle. If I ask for tea, it returns to idle by providing me a cup of tea. If I need sugar, I need to make sure that I have entered sugar and then the cup of coffee or a cup of tea. Of course, if I press sugar again, I come back again as if I have unselected sugar. Oh, by mistake, I pressed sugar. So these would be the operations which I have. Now, let us build this as a graph. How do I now do the same state-based testing? Would that state-based testing which we discussed in the previous topic be helpful over here? Of course, yes. So I want to cover states, I would like to cover transitions, and I would like to make sure that I cover paths. A path which allows me to insert a coin and get a cup of coffee. I have a use case view, or I actually have a path view that I need to cover T1, T2, T3, T4. So at this point in time, it would be a nice idea for us to construct that graph. So let's get rid of these lines and actually construct a graph. And we'll do the graph construction along with the errors corrected. Okay, so what does that mean for us? Let us use another color. So I'm going to use a purple color. So I've got this is one of my nodes. I have another node here, another node. So I've got, yes, 1, 2, 3, created my flower here. Then comes in my coin inserted. Then comes my coin returned. From here, my coin returned. Coffee, tea without sugar, sugar, no sugar, coffee with sugar. This was coin returned, and now I also have tea with sugar, coin returned. So you can actually see that this graph is what has come to me, where I'll be able to now do transitions. I could do state A, state B, and state C. So there is, let's look at another color which can distinguish. So I've got state A, state B, and state C. Then come in transition. Which transition would I take, and how would I really get my entire transitions tested? So all transitions at least once. Quickly my use cases turn on, which I say I'm going to insert the coin and remove the coin. I'm going to insert the coin and remove the coin while I am in stages idle and coin inserted, as well as after I have pressed sugar. So I'll be able to get not only transitions, but I have also gone through the states. And then ask for coffee and tea with and without sugar, and press coffee, tea and sugar at all places. And I would be able to test the whole vending machine. You can see that a methodical way of creating a model, a state-based model, will help create test cases with the elements that are available in terms of states, transitions, as well as paths. It not only makes it simple, it also provides a rigor to the entire process. Also provides a notion of completeness and in fact correctness. While this vending machine is still simple, you will also find a lot of complex problems that could be taken up to solve based on this particular model. So model-based testing is a very, very involved and a very profound technique for us to use for getting to very, very good test cases for some of the complex problems. Also takes us to state-based testing, which is another element, another tool in our arsenal as a test engineer. So I hope you enjoyed this. Thank you very much.